In this video, I am going to discuss about the thermocouple temperature transmitter with respect to the data acquisition. Means how the thermocouple signal is received by the transmitter and how it is converted to a temperature value. Transmitters are widely used in industry for converting the sensor output to a 4 to 20 milliampere signal. And this 4 to 20 milliampere signal is transmitted from field to the control room where the control system is located. So in industries, different types of thermocouples are used like K-type, J-type, S, R, and so many other types. And each thermocouple is having specific advantage, and depending upon your application requirement, the type of the thermocouple need to be selected. Here you can see thermocouple is connected to the transmitter, which converts that signal to 4 to 20 milliampere signal. Here this is the power supply for the transmitter and this is the load for the transmitter. This load will be an analog input module of the PLC, or it may be a chart recorder, or it may be an indicator. So here you can see the operation of the thermocouple. So thermocouple is formed by joining two dissimilar metal, here material 1 and material 2, and by joining these different materials, so two junctions are formed. One is known as hot junction, another is known as cold junction. And the output of the thermocouple is the EMF that is proportional to the temperature difference between the hot junction and the cold junction. If the cold junction is at 0 degrees centigrade, then the EMF is directly proportional to the hot junction temperature. But in practical cases, the cold junction temperature is not 0, it is at a certain ambient temperature. So the ambient temperature need to be measured and this output need to be added to the actual thermocouple output. And this process is known as cold junction compensation of the thermocouple. Here you can see how the cold junction compensation is done. So the cold junction temperature is measured by using an absolute temperature measuring sensor like RTD, IC based temperature sensor or a thermistor, and the output corresponding to this temperature is added to the actual thermocouple output, and the final output is proportional to the hot junction temperature. Here you can see a typical thermocouple temperature transmitter block diagram, which consists of various blocks like ADC. ADC stands for analog to digital converter, which converts the EMF output of the thermocouple to a digital signal, and this digital signal is processed by the processor that is present on the transmitter. And this is the ambient temperature measuring sensor that is used for providing the cold junction compensation for the thermocouple. And this is the DAC block. DAC stands for digital to analog converter, which converts the digital signal of the processor to 420 milliampere analog output. And here you can see the lookup table. Lookup table is a widely used concept in embedded systems for storing the data in permanent ROM memory, and this data can be easily accessed by the processor with minimum operations. So if you take the temperature transmitter, so what is the data that is stored on the lookup table? Here you can see. So this is the chart for a type K thermocouple, which shows the EMF output for different temperatures, and this is the data that is stored on the lookup table. And whenever the processor reads 2.023 millivolts, then this displays 50 degrees centigrade by reading the data from the lookup table. Similarly, if the processor reads 4.096 millivolts, then this displays 100 degrees centigrade by reading the data from the lookup table. If the processor has not used a lookup table concept, it need to perform so many mathematical operations like multiplying the ADC output with some factors like Seebeck coefficient, need to be done some linearization algorithms. So all these operations will make the processor slow. So here you can see different lookup tables are used for converting the EMF output of the thermocouple to a temperature value. Here you can see this is the lookup table that converts the ambient temperature sensor value to a temperature, and this temperature is again converted to millivolts because each thermocouple is having a different EMF output per degree centigrade, and the millivolts is again added to the actual thermocouple output, and the final output of the sum block is the EMF that is proportional to the temperature of the hot junction temperature, and this millivolts again is converted to temperature value by using this lookup table. Thank you for watching my video.